Hi, my name is Fred Mastropasqua. I'm a Scrum Alliance certified Scrum trainer with Clearly Agile. Today I'm going to talk to you about velocity and how do you predict velocity if you're using relative sizing. I recommend watching my last video on relative sizing where we talked about what that means and some of the pitfalls teams fall into. Right? If you watch that video, then you'll recognize some of these elements up here in the drawings, but we're going to talk today about relative sizing. So let's say I have a product backlog. And I have this product backlog. We've seeded the product backlog. We have a bunch of product backlog items in here. Maybe they're written in the format of a user story, maybe not. Right. And I need to figure out how long is it going to take to get this work done. Right? What's that timeline look like? As we talked about relative sizing, right, we're using the story point system, right? Modified Fibonacci sequence. And there's no unit of measure of time associated with these points, right? No unit measure of time associated with the points. So I might have, in the backlog, I need to set a baseline. I need to create a baseline. So I'm going to ask the team, hey team, looking at this product backlog, what do you think the easiest thing to accomplish is? Not time-wise, just effort-wise, right? What's the smallest thing in here? And so the team's going to look at the backlog and they'll say, okay, of all these things, we think this one here is the easiest thing to get done. And they're going to put a point on it. So I'll say, okay, if that's the easiest, let's create a baseline and making that a 2. Just in case later something comes in that's even easier, we can still go down a little bit. All right, if that's our baseline, this item amount of work is 2. Doesn't mean anything yet, right? I now, to do relative sizing, going to compare other things to this baseline. So I look at the first item in the list, and I ask, is this more work, less work, the same amount of work? Right? And the team looks at it, they say, okay, it's more work than the 2. Okay. How much more work than the 2? And they say, it's about double the amount of work. All right, well, double will be 2 times 2. All right, that's 4. There is no 4 in the story point system, so we'll make this a 5. We'll go up to the next number. All right, next one. Is it more work, less work than the 5 or the 2? And they'll say, oh, you know, wait, it's more work than the 5. Okay, is it double the amount of work of the 5? No, it's not double. All right, so it's not a 10. It wouldn't be a 13. So it's more work, but it's not double, so we'll make this an 8. All right, how about the next one? And we keep asking this question every time we look at the next item in the backlog. We discuss maybe why it's so much more work or less work, but we agree that this one here is, we'll say, is more work than the 2, but not as much work as the 5. Great, that means it's a 3. And the next one, same amount of work as a 5. Awesome. Right, and we keep doing that. This one we realize is more work than the 8. Right, it's double the 5, so that's a 13. As we get farther down our backlog, we might have items that are larger. Right, 40-point items, maybe we have a 100-point item here, maybe we have another 5, and then maybe down here we have a 13. I've now relatively sized the product backlog. Looking at these items, right, relative to each other, what's their relative size? Not how long it takes you, but relative size. Now, the ones that are 40s and 100s down here, maybe the 21s, right, there's more uncertainty there, right? There's a lot more uncertainty here in the larger numbers. Right, and I have to decide as, you know, the product owner, or I have to decide as whoever needs this information, am I okay with that uncertainty for this estimate, or do we need to break these down to smaller pieces to get a little more accurate on the estimate? But let's say that I have this total number, the whole thing sized, and I add this up, and I'm just going to make up a number here. Let's say it adds up to 300 points, right, of work, right, 300 points of work. I now have the total number of relative size points in the product backlog, either for a first release or for the whole thing. And the team starts working, right? The team starts working. In the first sprint, they get some work done. And let's say that equals up to, we'll say 15 points worth of work. Right, 15 points worth of work. I now take 300, that's their velocity, right? They do 15 points of work. Velocity is measured in 2 ways, either yesterday's weather or the rolling average of the last 3 sprints, right? Those are the 2 ways you measure that. So yesterday's weather simply means, what did we do last time? Last time we did 15 points, so I'm going to use 15 points to predict the rest of it. All right, so I would take 300 divided by 15, and that would tell me exactly how many sprints are left, right? That would tell me exactly how many sprints are left. So 300 divided by 15, their velocity, that's going to give me a number of 20 sprints. All right, sprint is a time box of 4 weeks or less. Let's assume these are 2-week sprints. 20 sprints times 2 weeks equals 40 weeks to get all this stuff done. Really, it's not 300. Really, it's 285 because they already did 15 points. All right, so that gives me 19 sprints times 2 weeks. Right now, we're looking at 38 weeks left. right? But that's how I would predict using relative size. Team does some more work here. Maybe this time they do 20 points. They do a little bit more work here, and then now they do 25 points. I'm going to use the rolling average of the last 3 sprints of 20 points to predict how much longer it's going to take to get done. Now, why is this better than maybe time-based estimating? Right? I could do time-based estimating. If I was to estimate everything here based on time, right? To me personally, that's not going to be accurate because time-based estimating is a lot harder, right? So that's like asking, again, to the previous, the other video we have on relative sizing is exactly how many ounces of water are in these cups, right? Exactly how long will it take you to get this work done? That's always, we're pretty inaccurate sometimes on those time-based estimates. But I could estimate everything based on time, and I get to 1,000 man-hours, right? The cone of uncertainty, I start out with a plus or minus big scale, and eventually as we get closer to the end of the project, we're getting more narrower and narrower down to our estimates. But I estimate everything here in hours. Maybe we do the first sprint, we do the second sprint, we do the third sprint, and then I ask the team how long till we get all the rest of the stuff done. Well, the things we did up here are really going to affect the things down here. We're getting better with the product, we're getting better with the tooling, we're understanding the business more. And so we're going to be able to become a little faster down here. That means the hour estimates on these, the time-based estimates on these items down here are no longer accurate. So to get a prediction, I have to have the team re-estimate everything all over again. Right? And then as we get farther down the backlog, and I want to know how long till we get done, I got to re-estimate everything again, right? In order to figure out how much time is needed. And that's going to take time. Right? The other way here is if it's relative size to each other, then as we get faster, we get better with the product, we understand more, and these things we're gonna be able to do these items faster. We do not have to resize these points because they were relative already to begin with, right? They were relative sized. So that means is we're gonna be able to pull more work in to the sprint. Our velocity is going to increase, and eventually our velocity starts to stabilize. But over time, our velocity increases and then starts to stabilize. As we get smarter and smarter, we're able to pull more work in. So I don't have to have the team go back and resize all these items. All right, to give you my car washing example, let's say we have a car, and we say a car is a 1x. Relative size to the other cars, right, this is a 1x. Another car like it is the same. If we have a van is a 2x. We'll say a van is a 2x, 2 times more than a car. And if we have a bus, we'll say the bus is 4 times more work than the car. So if I know in a single day, right, day 1, I know that you can do 10 cars in a day, right? Now that's your velocity. You wash cars for a day, and you end up doing 10 of them. That's your velocity. I can now predict, right, if I have 50 cars in the parking lot left over still to go, then I know it's going to take you 5 days to wash all those cars because you're doing 10 cars a day. I'm not asking you how long does it take you to wash a car. I'm saying relative to this car, is it 1 times, 2 times more work, 3 times more work? If I have on the next day, I have a bus or a van, I know you can do 10 cars, 5 vans, right? Or maybe 2 buses and 2 cars. That's what you can fit in your velocity. As you get smarter about washing cars, right, day 2 and day 3, and you start learning the tooling, you're able to get better at your job, your velocity is going to increase. Eventually you're doing, maybe after a week, now you're doing 15 cars a day, 15x. Right? I can now use that number to predict how long it would take you to wash various sizes of vehicles, cars, buses, motorcycles, if everything is relatively sized. Right? Not time-based estimate, not how long does it take you to wash this bus, and how long does it take you to wash this car. Right? As you get faster with the car washing, your velocity is going to increase, and I can use that velocity, number of points, to figure out the rest of the timeline. So that's velocity, that's how it's used. Right? Now, if you end up doing, there's some pitfalls to avoid. If you end up doing some calculations here, and you calculate, and you're calculating, okay, if we do 300 points, 285 divided by 15, 38 weeks, and we're like, that's going to miss our date, right? And you realize that's going to be an issue. What you don't want to do is pressure the team to change their estimates, and you don't want to pressure the team to increase their velocity. I meant to say, right? So if you realize we're going to miss the dates, what you don't want to do is pressure the team to increase their velocity and put all the pressure just on that, right? You got to increase your velocity. You got to increase your velocity. You got to increase your velocity. because when they hear this in the back of their heads, when they go to size these things as things come in, right, or they go to resize things based on new information, right, that's the easiest thing they can do to increase their velocity. Easiest thing they can do to increase their velocity. Maybe we say add team members. We could do that. That could work. And that would be better. The downside of that is we don't always have the budget for that, right? Adding an FTE. Also, as you increase, if you're increasing velocity and you add a team member, what usually happens is velocity dips, and then eventually it comes up past the original point, right? But do you have time to deal with that dip in that learning curve of people helping that team member out? And maybe you do, especially if it's a long term. You could add another team. That'd even be better. That'd be the best way to do this. Add another team, and they're working off the backlog as well, right? That'll increase your velocity significantly, right? Or, right, even easier than that, though, is a team could just change their estimates. 5s become 8, 8s become 13. There you go, product owner. We're now doing 40 points a sprint, and you're all excited because you're like, yeah, we're going to hit our dates, right? Yet you've just fooled yourself, right, in that estimate because you've pressured the team on changing their increasing their velocity, right? And so you have to be mindful of that. The estimates are owned by the team, I had a story once. I was working with a team once as a coach, and the team asked me, like, we don't understand relative sizing, right, which I talked about in the other video, and so we don't understand how this works. So I went through the examples, and then they told me, well, the client has added to our contract that we have to deliver 42 points a sprint. That's in the contract. So what did the team do? They adjusted their points to always make sure they hit 42 points a sprint, right? And I said, you're right. It's pointless. You basically might not even do story points. You just do time-based estimating. I don't even know why you're bother estimating. If you're forcing the team in a contract to do 42 points a sprint, then they're just going to manipulate the numbers to do 40 points a sprint. You're defeating the whole purpose of velocity and relative sizing. So that's it. I hope if you have any comments or questions, feel free to put them below. Again, my name is Fred, Mastropasqua with Clearly Agile. Thank you very much.